Hello everyone. In this video, we are going to explore a new feature of LuBan. It is called Dual Grid. Let's open LuBan software. Generate a simple 3D shape. I'm going to generate a cylinder. So this is the simple shape that we are going to begin with. And we will use mesh LuBan method grid to process the cylinder. Grid. In the previous version, we do not have the dual option, so everything behaves as if the dual is set to no. You can change the cell size, the thickness, and the angle of the grid. For instance, you can tilt the grid. In the new version, we have added an option, dual. So set it to yes, and then you will have two additional parameters. One is called base thickness. We cannot see the base thickness at the preview mode. We can only see it when we click Save Model to generate the dual method, to generate the dual objects. Secondly, we have a tolerance setting. It is the fitness, it controls the fitness between two grid objects. I recommend you to set it to -0.5 or -1 so that you have a flexible fitting. Hit the Enter key after you change a value in a text box. Now we are about to ready to generate our first dual grid. Click Save Model and select a parent folder to save it. I'm going to put it on the desktop. It takes a little while to generate the dual. So what does this object mean to us? When you use the object select option, you will be able to see the two objects highlighted in the view. If it's still not that clear, you can use Object Explode option, keyboard shortcut E. It has generated two objects. The first one is the red one, and that is the output in our previous method. It is a grid. The second is the white object. The white object is disconnected everywhere and only connected at the base. So when you print out these two objects, you can insert the red one into the right objects to produce the original shape of the object. And the gap between the red and white is -0.5, the tolerance. Okay, these white pillars support the white pieces of the white object. You may take a closer look. Each block in the white object are actually disconnected. Otherwise, the red one cannot be inserted into it. Now I'm going to change the angle to 90 degrees. So this will be our next experiment. Save the object. This is what I get. Okay, that's the red grid, and this is the white hosting grid. We can certainly use different patterns. The red and white grid. And let's open the STL to take a look. There will be two STL generated, grid 1 and grid 2. Grid 2 is the hosting grid. Each block is disconnected from the other ones except at the base. And the grid, the coin-shaped grid, can be inserted into the hosting grid. This method is applicable to any STL, provided that the STL is free from defects. If you have used LuBan before, you know that some defective STL can be cut by LuBan cutting algorithm. But if the cutting plane goes through the defective region, there will be defects propagated to the cut parts. This method has a more stringent requirement on the input STL. If there is defects, it will not process. For example, I have a cow model, and this model has defect. The tail intersects the body. It's a self-intersection defect. And when I try to use the grid option to process the model, oh wait, too big. Let me set it. It has generated too many grid. So if I try to save it, you will get a message: fail to generate the grid. And that is caused by the defects in the model. Let's process a model that doesn't have defects. The duck model is free from defects. We can use the coin shape, or we can also use a user input pattern. The user input pattern, I'm going to use this one, the Voronoi pattern. So I will open the Voronoi pattern. Okay, it will take a long time to process because the duck is a dense mesh, and the Voronoi pattern itself is also a dense mesh. Let me try some different angle, maybe something like this. Okay, and let's give it a go. Save to the desktop. It will take quite a while, probably 1 minute. So you can fast forward this video to the end to see the results. Still processing. Let's see how long it takes. Apologies that I do not know how to crop some of the based on the timeline of the video to directly show you the results. So I'm just going to wait here. And when you watch the video, you should fast forward to the end of the video to see the results. Okay, it's coming up. That is the dual grid generated by the Voronoi pattern and the duck. So the block of the duck is connected to the base, and the red one is the grid model. The white one is the base of the grid. We open the 2STL. That's the base, and this is the grid, the duck grid. The gap in between is set by the tolerance. Okay. That is all for the new feature. I hope you like the new method. Thank you very much.